Good day. My name is Cyrus A. Gonzalez, and I'm here to present my research paper entitled Implementing the Usage of Ocean Wave Energy to Reduce Using of Fossil Fuel. The world has for generations been enjoying the benefits of energy source, namely fossil fuels. Today, humans practically depend on these fuels consisting of petroleum crude oil, natural gas, and coal. We all know that in today's world or in today's time, people usually use energy source, especially fossil fuels, um, into our daily life, which we all know is very harmful to our environment. These fossil fuels, for example, petroleum crude oil, natural gas, as well as coal, can do a harmful effect to our environment, causing different events like we are experiencing right now, the global warming. Renewable energy resources need to be explored to maintain and meet energy demand and replace the slowly depleting fossil fuels. And we should look or we should find for renewable energy resources in order for us to overcome or to stop the using of fossil fuel, not actually stop but to reduce the using of it in order for us to reduce as well as the effects of it to our environment. The need for energy resources for future is recognized by all countries. Their economic growth and self-reliance will depend mainly on vital field of energy. The increase in oil prices, the depletion of coal resources, the possible threat to the environment due to influence from fossil fuels and nuclear power plants has prompted the technological development and the utilization of renewable sources of energy such as solar, wind, biological, and ocean energy programs. As we are experiencing these effects of using fossil fuels, humans are also um, thinking ways in order for us to reduce the using of fossil fuel for us to reduce also the effects of it in our environment, which we came up um, the utilization of renewable sources like from solar, wind, biological, and our topic, which is the ocean energy wave. The sources of energy from the seas are waves, tides, currents, salinity gradients, and natural thermal differences in the oceanic water. The wave energy is suited for countries with vast coastline and high waves approaching the shore. It is free from environmental pollution and continuous. These waves are never going to cease. This source of energy, this water and this wave energy is a very good thing to use with because as we all know, waves are never going to cease or it will never end as long as there is an ocean water, which we all know is a very big part of our planet Earth. So it is a very good choice for us human. The extraction of energy from the waves can be a viable solution to the enormous power requirements of a country like Malaysia, having a vast coastline. The present technology of wave energy conversion may be economically not encouraging when compared to the conventional energy sources like fossil fuel, hydropower, etc. But wave power could be economically viable for remote islands and mainland. Yes, it is not encouraging to those countries with with lower economic value like the third world countries because they don't have enough budget for those wave energy. But we all know that we should do an effort in order for us to have a greater effect in our life. Objectives. In this research paper, the main objective is to minimize the usage of fossil fuel by conducting a study of how to maximize the power of ocean wave energy, as well as studying the machines or the devices that are applicable or can be used to transport and capture energy from ocean surface waves. Methodology. The method used in conducting the research paper is Online Research Method or ORMS. ORM are ways in which researchers can collect data via the internet. They are also referred to as internet research, internet science, or iScience, or web-based methods. Many of these online research methods are related to existing research methodologies but reinvent and reimagine them in the light of new technologies and conditions associated with the internet. The field is relatively new and evolving. The growth of social medias, a new level of complexity and opportunity has been created. Inclusions of social media research can provide unique insights into consumer and societal segments and gaining an emotional measure of a population on issues of interest. Discussion. According to Nyechokwu and Bryan, atmospheric pollution from the burning of fossil fuels, depletion of the Earth's natural resources, and the fear of radioactive emissions from nuclear plants make the concept of renewable energy resources a primary concern and an attractive form of alternative energy today. Ocean waves are one of the world's most abundant sources of renewable energy, generated as a result of wind blowing over the ocean surface. Since winds themselves originate due to an even heating of the atmosphere by the sun, wave energy may be seen as a byproduct of solar energy. Wave power refers to the energy of ocean surface waves and the capture of that energy to do useful work, including electricity generation. During the next 20 years, experts foresee a need of 1,500 gigawatts of additional power supply to meet new demand. This equals to the 1,500 power plants that are 100 megawatts each and 59 million barrels of oil consumed in each day. The World Bank estimates that the developing countries alone will need to spend 100 million each for the next 30 years installing new power plants, most of which will be in equatorial zone. These are astronomical figures that could mean enormous quantities of fossil fuel and 2.2 billion tons of CO2 released to the atmosphere per year. Hence, an urgent need to switch to alternate energy. Among the alternate energy resources, ocean wave energy is considered one of the most promising alternate energy resources. It has high availability factor, day as well as night, compared with other sources such as wind energy or solar energy. So for the next 20 years, our world will experience its highest rate of wattage of energy needed per day. For example, those countries who are in developing countries need to spend 100 billion year for the next 30 years in order for us to supply energy appropriately or in the right amount. So those sources of energy, we should change them. We should change them because they are affecting our environment. But we need those high wattage of energy, so we should look for an alternative sources of energy who are um, who have a high availability factor day and night, like wave energy, because wave energy does not end day as well as night, unlike solar energy and as well as wind energy, because solar energy we can only harness it during the daylight, while the wind energy, if we only have an wind in a specific location. Economic considerations. It is interesting to examine the criteria used when renewable energies are considered from an economic perspective in comparison to criteria used for other sources of energy. In the case of fossil fuels, it is accurate to calculate the sale price of 1 kilowatts per hour of electricity and deduce from this that if the price is lower than for wave energy, then it is the cheaper option. How could it be without taking into account the hidden costs associated with fossil fuel, such as the amount of money now devoted to researching the extent and possible ways of alleviating the damage caused to the environment? Neglected also are the research costs spent on developing the fossil fuels to their present levels of efficiency, which far exceed those renewable energies. It has been estimated that if less than 0.1% of the renewable energy available within the oceans could be converted into electricity, it would satisfy the present world demand for energy more than 5 times over. The problem is that it is not easy to harness this energy and convert it into electricity in large amounts. Thus, ocean wave power stations are rare. Environmental implications. Ocean waves are a source of clean, natural, and renewable energy. The harnessing of wave power does not cause large carbon dioxide emissions, which would allow it to play an important role in counteracting the threats of global warming. There are no dangerous and harmful byproducts which are comparable to the radioactive waste produced in nuclear power plants. As with any interactions between humans and the rest of the natural world, there is, however, an impact on the environment, some aspect of which being negative, though not all, offshore devices, for example, would help to reduce coastal erosions, as the case with the Bar Beach at Victoria Island, Lagos. The construction of large offshore devices could have serious consequences for wave patterns and sedimentation rates. In areas in need of coastal protection, this may be benefit. The impact on drift patterns and secondary effects on the local ecology will be the main point in further research in the study of these devices. So even though we think that this is a very safe, very clean source of energy, it does have a negative effect to our environment. Because as I stated, there is an impact on drift patterns of the wave itself. So there are many further research and studies to these devices for us to be clean and not harmful sources of energy. Materials and methods. First, the basic physical concept. In general, large waves are more powerful. Specifically, wave power is determined by its wave height, wave speed, wavelength, and also the water density. Wave size is determined by wind speed and fetch, which is the distance over which the speed excites the waves, and the depth, and also the topography of the seafloor, which can focus or disperse the energy of the waves. A given wind speed has a matching practical limit over which time or distance will not produce larger waves. This limit is called a fully developed sea. Wave motion is highest at the surface and diminishes exponentially with depth. However, wave energy also presents as pressure waves in deeper water. The potential energy of a set of waves is proportional to wave height squared times wave period, or the time between wave crests. Longer period waves have relatively longer wavelengths and move faster. The potential energy is equal to the kinetic energy that can be expended, so wave energy is expressed in kilowatts per meter. So in figure 1, we see when an object moves up and down on a ripple in a pond, it experiences an elliptical trajectory. Same as this in the figure 2, schematic of an oscillating water column. When the wave goes up, brings air pressure that can create an effect to those dynamo connected to the device, which we all know can produce electric energy and electricity. So we have a formula. The formula below shows how wave power can be calculated. Excluding waves created by major storm, the largest waves are about 15 meters high and have a period of about 15 seconds. According to the formula, such waves carry about 1,700 kilowatts of potential power across each meter of wavefront. A good wave power location will have an average flux much less than this, perhaps about 50 kilowatts per minute. The formula is power in kilowatts per meter is equals to A times T squared times T, which is equals to 0.5 the constant times H squared times T, where K is the constant, H is the wave height, crest to trough in meters, and T is the wave period, crest to crest in seconds. So here we have a device called an OWC or oscillating water column. So according to the Department of Naval Architecture and Marine Engineering, this system is considered to be the closest to commercial maturity, as the principle of operation is simple and the construction uses conventional technology. The major component of an OWC system is a chamber, which is a fixed structure with its bottom open to the sea. The wave motion inside the chamber alternately compresses and decompresses the air that exists above the water level inside the chamber. As a result, an alternating stream of high velocity air is generated. This airflow is driven through a duct of a turbine generator that is used to generate electricity. Turbine generator use is a special turbine which has the unique property of turning in the same direction regardless of which the air is flowing across the turbine blades. Thus, the turbines continue turning on both the rise and fall of wave levels of the chamber. Turbine drives the generator which converts this power into electricity. So that is one devices that we can use in order for us to harness wave energy. It is a very good device because, as it is stated, it is the closest to commercial maturity because it is very conventional technology. Macro model of the chamber was designed and installed on a permanent base, which can be moved back and forth along the towing track of the channel at Marine Hydrodynamics Laboratory of the Department of Naval Architecture and Marine Engineering at University of Michigan. So they created this device. The characteristic of wavemaker and water flume are taken as follows: tank length, which is 109.70 meters, tank width, which is 6.70 meters, and tank depth, which is 3.05 meters, and periods of waves is 0.63 seconds to 2.2 seconds, and the wave heights up to 0.33 meters. This type of wavemaker is a plunger type capable of generating regular and irregular waves, computer generated for any irregular wave spectrum. So here in figure 4, we can see a tree picture which consists of the OWC device and how it is built. The parabola design of the device, the OWC or the conversion of wave motion to airflow, and also the model the model LC, which always turns or spin at the same side, even though the air is moving forward or in backward way. So we also have an existing wave energy plants in the world. First is in England. One set of OWC wave power station with installed capacity of 70 kilowatts was built in the west of England under the support of the Department of Energy in 1991. Used a twin-rotor symmetrical wing turbine generator, so the average electric power generation was 7.5 kilowatts. There are also an wave energy plants in Norway. One set of multi-resonance OWC wave power station with installed capacity of 500 kilowatts was put into operation in an island near Bergen of Norway in 1985. It used a symmetrical wing turbine generator, but in December 1988, the structure failed during a storm. Here in Asia, there are also wave energy plants in Japan. One set of OWC wave power station with an installed capacity of 30 kilowatts was put into operation on the shore 99 miles away eastern to Tokyo in 1988. It used a conventional impulse turbine generator. The average electric power generation was 6 kilowatts. The power station has been operating in a normal condition for 10 years. So there are challenges in implementing this wave power or wave energy. The challenges of the challenges of wave power are: first, efficiently converting wave motion into electricity. Generally speaking, wave power is available in low speed, high forces, in motion, which is not in a single direction. Most readily available electric generators are being operated at higher speeds, with lower input forces and rotate in a single direction. So the common electric generators does not meet the requirements of of the wave motion of the wave power. So the second one is constructing devices that can survive storm damage and saltwater corrosion. So likely sources of failure include says bearings, broken welds, and snap mooring lines. Knowing this, designers may create prototypes that are so overbuilt that material costs prohibit affordable production. It is the second challenges um, those who want to have this wave power are going to face, which is the survivability of the materials used in creating these machines or these devices. We the creator or the designer can create prototypes which is more stronger, but the problem is this much costly, or it can cost a high amount. So the third one is low total cost of electricity. Wave power will only be competitive when total cost of generations is reduced. The operative effective design will be the one that develops the lowest cost system, which include the primary converter, power takeoff machine, mooring system, installation, and maintenance procedures. So here also the problem is the budget, or in um, because this type of machine is very costly, or it can cost a lot of money, because first, water is one of the most dangerous enemy of the metal. We all know that, and we should use materials which can survive this type of enemy, as well as also these machines can cost, or can cost also a lot of money, because there are many machines or many devices which are going to be inputted into that machine, like primary converter, power takeoff. Also, the maintenance are included, so it can cost a lot of money. The possibilities for future development in the Philippines. At its present stage of development, Wave power is an ideal energy source for small-scale utilization such as island communities, oil rigs on the ocean, etc. This has important implications for Philippines, particularly regarding the saving of fossil fuels currently being used by such communities. Also, worth noting is the fact that Manila and other highly populated parts of the country are close enough to the ocean to benefit from this form of energy, thus reducing greatly the cost of using fossil fuel. Large-scale harnessing of wave energy will be made a reality within the next 10 to 15 years, and this will be possible if sufficiently large resources are made available now to a strategically planned program for Philippines so as to develop her own wave technology. Onshore and nearshore OWC devices are at an advanced stage of prototype development with device teams in Japan, Portugal, and the UK. Philippines is lagging behind in these developments. Therefore, research funds should be directed also in the source of renewable energy program. As of 2016, according to the Department of Energy or DOE of our country, roughly 76% of the Philippine sources of energy came from fossil fuels. The remaining percent was mainly attributable to the renewables. Interestingly, ocean energy is still not part of the current energy mix. The main focus of the study is to see the technical economic feasibility of harnessing energy coming from waves. Specifically, this work intends to point out and quantify the potential sites to deploy wave energy converters relative to their source profile of specific locations situated in the 5 coastal regions of the Philippines. So there are 3 WEC or wave energy converters were assessed, such as Aquaboy, Pelamis, and Wave Dragon, in consideration of their advanced technology readiness level. So furthermore, data needed for estimating the source potential of each site came from the SURF forecast. It is a website providing wave profile forecast based on National Oceanic and Atmospheric Administration. WaveWatch 3 model. Data were gathered for 1 year on a 3-hour interval per day. Meanwhile, prior to assessment, the data were first validated by the hindcast data of MetOceanView, a high-resolution web-based weather forecasting tool using MetOcean solutions. So, based on that website, results revealed that there is around 10 to 20 kilowatts per minute of wave energy flux scattered in various coastal areas of the Philippines. Lastly, the economic impact of developing wave project has been assessed, considering base case, optimistic and pessimistic scenarios to be able to account for any possible uncertainties. So in conclusion, it has been shown from this research paper that the ocean wave energy is a viable source of cheap renewable energy that is capable of solving the electricity problem here in the Philippines. So harnessing the energy from the ocean front, which were wasted energy to us, can be put to effective use, creating more jobs if the power plants are installed. Although this kind of project takes a lot of money, time, and effort, but if this became a successful one, it will bring an energy that is healthy and helpful not only for us, but for the environment. Therefore, it is recommended that more funds should go into the research of this viable source of renewable energy. And that's all. I hope you understand this research paper. And thank you. God bless.